Okay, we're looking at problem 12 in the chapter 14 assignment. They give you some partial output from the simple regression tool, the analysis of variance, as well as the information for the y-intercept and the usage variable, which is the independent variable. This is for the maintenance expense and usage for a particular brand of computer terminal. We want the estimated regression equation. We also want to perform a t-test to determine whether or not there is a relationship, a significant relationship, at a 0.05 level of significance between the independent and the dependent variable. They're asking for a t-test where they want you to calculate the test statistic and the corresponding p-value based on that test statistic, and then answer 3 questions. So let's look at the output to start with. The coefficients. This coefficient corresponds to b sub 0. The second coefficient corresponds to b sub 1. If you have the reference sheet for simple regression equation, that is available. You see the coefficients that correspond to b sub 0, b sub 1. In the second column are the standard errors for b sub 0 and b sub 1. We're not given this other information here, but if you had the full summary output, you could actually find the t statistic as well as the p-value. But we have to calculate these values. But you can see, even from this reference sheet, that the test statistic for each coefficient is simply the coefficient itself divided by the corresponding standard error. So that's what they want you to understand and be able to calculate. So looking at the output, b sub 1 would be the 0.8951. The standard error of b sub 1 is the 0.149. That would be our test statistic. So calculating that ratio gives us a test statistic, a t of 6.00738. And this is for 8 degrees of freedom. Alpha was 0.05 divided by 2, 0.025. To look up the p-value, we need to know alpha over 2 and the degrees of freedom. Back to the reference sheet again. The degrees of freedom is n minus 2. So the second value under degrees of freedom is the degrees of freedom for the problem. So using this t statistic at 8 degrees of freedom, we would look up the corresponding area that this represents using the t distribution table. So looking at a critical values of t table, the t distribution table for 8 degrees of freedom, our test statistic value is 6.007, which is greater than the highest t value they have on this table, which is 3.355. Our value is 6, which is almost twice this highest t value on the table, And it's hard to see, but this corresponds to an area under the curve of 0.005. And you can use the tables that are available in the reference material module. So if 3.355 corresponds to an area under the curve of 0.005, a test statistic value of 6 would be a much smaller area because it would be much further out on this curve. The area would be at least half of 0.005. If you really wanted to calculate that area of the t-distribution for a two-tailed test using that test statistic of 6.00738 with 8 degrees of freedom, you could use the Excel built-in function to calculate that number, which turns out to be 0.000321. This p-value is even smaller than I estimated. So filling in the coefficients from the output for the y-intercept and the coefficient on the usage variable x, we round our test statistic to 2 decimal places. And if we round our p-value to 2 decimal places, we simply get 0. This enables us to reject the null hypothesis and conclude that the monthly maintenance expense is related to usage because our slope is not equal to 0 based on this test. And we can conclude that the regression equation provides a good fit. Now, obviously, we'd look at some other indicators as well of fit, such as the R-squared value. They didn't ask for this, so didn't give us that information in this problem.